Good evening, everyone. Welcome to Science Academy. So today we'll study about the phenomenon that is the radioactivity. So generally, what happens whenever a nucleus of an atom it disintegrates by the emission of the radiations like alpha particles, beta particles, gamma particles, and many more, along with a daughter nuclei, then the kind of phenomenon is called radioactivity. So radioactivity is the phenomenon of spontaneous disintegration of the nucleus of an atom with the emission of one or more radiations like alpha, beta, and gamma rays. So naturally occurring heavy nucleus is generally unstable. So here the heavy nucleus means the nucleus which contains higher number of neutrons and protons, that is high number of n and z. So we know that n plus z equals to a, that is atomic mass number. So generally we refer the heavy nucleus which has higher value of atomic mass number a. So it is generally unstable. So whenever it spontaneously emits a particle, it forming the different kind of nucleus, as I have mentioned, that is the daughter nuclei. So such kind of nucleus which emits a particle forming a different nucleus, the kind of nucleus is to be radioactive, and the process of transformation is called the radioactive decay. So spontaneous here, the word it is in the sense that it occurs by itself. So we don't need any kind of initiation, or it cannot be ignited. Okay, that's why uh, it can be initiated, stopped, or accelerated by changing the chemical conditions along with the physical conditions. Here the physical conditions refer to temperature, pressure, etc. So the outward, we cannot apply some outward kind of initiations by chemically or by physically. That's why the process is said to be spontaneous, it occurs by itself. Okay, so the great phenomenon is was discovered by the French physicist, which is known as the Henri Becquerel in the year 1896. So the kind of radioactive elements are, for example, uranium, radium, polonium, thorium, etc. Next, we will discuss about the radioactive decay loss. So the law states that the number of nuclei disintegrating per second of a radioactive sample at any instant is directly proportional to the number of undecayed nuclei present in that sample at that instant. That means we can say that the rate of decay or the decay rate is proportional to number of undecayed nucleus. Okay, so higher the decay rate, we can say that higher is the number of undecayed nuclei left. Let n0, this is the number of radioactive nuclei present initially at t equals to 0 in a sample of radioactive substance. Okay, that means at time t equals to 0, that is at initial time, let n0 be the number of samples present. And we take capital N, this is the number of radioactive nuclei present in the sample at any instant t. Okay, whenever we see at any instant of time t, we observe there are n number of radioactive nucleus present at that instant of the sample. And dn, this is the number of disintegrated radioactive nuclei in the small interval dt, that is from time t equals to 0 to from time t equals to t, there is a little bit of disintegration takes place, and that is denoted by dn. So according to this law, we can say that the rate of decay, this is proportional to the number of undecayed nuclei, where the rate of decay is dn by dt with a negative sign because it decays, it disintegrates. Okay, and this is proportional to n is the number of radioactive nuclei present at that instant. We can see that this is the undecayed nuclei number. Now the proportionality constant can be Now the proportionality constant can be omitted by replacing a constant which is called lambda here. Therefore we can write dn by dt, this equals to minus lambda n. So lambda is called the decay constant, or we can call this is the disintegration constant. Okay, already I have mentioned that negative sign shows that the n decreases with respect to time. Now we can just use the general mathematics that divide n in the left side and dt in the right side, that is dn by n, this equals to minus lambda dt. Whenever we will integrate, we will find integration of 1 by n dn, that is log en, and in this side this is equals to minus lambda t with addition of a constant. So we will use the conditions that whenever t equals to 0, the number of one decayed particles is equals to n0, that is the initial particles. So log e n0, okay, equation 2, using equation 2 log e, whenever n equals to n0, t equals to 0, we will get that the constant c equals to log e n0. Put this constant in this equation, we will get log e n0, sorry, log e n, this equals to minus lambda t plus log e n0. And just simple use the calculation that bring this portion in the left side, and we will find that n by n0, this is equals to e to the power minus lambda t, or also we can write that n is equals to n0 times e to the power minus lambda t. So this equation number 3, it represents the radioactive decay law. Okay, so it gives the number of active nuclei left after time t. So after any time t, whenever we have to find out the number of radioactive nuclei present at that instant, then this formula will be useful. And this curve represents the radioactive decay curve. So the curve, in this curve we have taken the time along the x-axis and the number of particles in along the y-axis. At time t equals to 0, there are maximum number of particles, that is n0 particles, which is the initial condition. And after, whenever the time increases and increases so on, the disintegration takes place. Okay, so that means the disintegration takes place, that means the number of initial particles, they starts to decay. So here n0 decreases down down down, and after some particular time the n0 becomes 0. So this is called the decay curve. So we can find some interesting thing, that the number of radioactive nuclei in a radioactive sample decreases exponentially from the now we have already find the formula, that is n equals to n by n equals to n0 e to the power minus lambda t. That means the decay is proportional, decay occurs exponentially. And the second one is that the larger the value of lambda, the higher the rate of disintegration. As lambda is called disintegration constant, whenever the value is higher, that means we have to understand that the decay is also higher. That means the nuclei disintegrates rapidly. Next thing is that a radioactive sample will take place infinitely long time to disintegrate. Okay, there are the samples, radioactive sample, actually they take a very long time to decay completely and becomes the, whenever that is the n0 decreases down